Soften slowly. Let the noise of the day move further away with each breath. You do not have to listen to every word that follows. The voice will keep going gently. Tonight, we are going to drift very slowly into the long, quiet story of the great deserts of our planet, where vast seas of golden sand move grain by grain across the patient horizon, where oases sit hidden like green islands in an ocean of warm stone, and where the deepest silence on Earth waits between every dune. This is the Circadian Institute. We make slow, scientifically grounded stories meant for sleep. The voice is steady. The pace is patient. Tonight's destination is the patient story of the world's great deserts, the immense Sahara with its endless dunes and ancient hamadas, the Atacama where rain is almost a memory, the cold Gobi steppe where camels walk through snow, the hidden oases drinking from fossil water deeper than human history, the camels and their patient companions, the salt roads that crossed continents, the brilliant dark skies above the dunes, and the soft, warm wind that has shaped the desert for ages. Subscribing is the small gesture that keeps these journeys reaching new sleepers each night. Tonight, we will travel together through the great deserts of our planet. We will visit the endless sand seas of the Sahara, the rocky stone plateaus that lie between them, the small green oases hidden among the dunes, the patient camels of the salt caravans, the Fennec foxes and the hidden creatures of the warm sand, the brilliant night skies above the dry plains, and many quiet places where the wind has shaped the land for ages. There is no hurry. We have all the time we need. To begin tonight's journey, we will visit the largest hot desert on our planet. It is called the Sahara. The word itself is borrowed from the Arabic word for desert, simply meaning the great empty land. The Sahara stretches across all of northern Africa from the Atlantic Ocean on the west to the Red Sea on the east, covering an area of roughly 9 million square kilometers, about the size of the entire continental United States. 11 different countries share some part of the Sahara. To the north, it touches Morocco, Algeria, Tunisia, Libya, and Egypt. To the south, it reaches into Mauritania, Mali, Niger, Chad, and Sudan. To the southeast, it includes parts of Eritrea. The borders we draw on maps mean very little to the wind and the sand, which simply pass over them in their long, patient way. In the very center of the Sahara, far from any sea, lie the highest mountains of the desert. The Tibesti Range rises in the country of Chad, with the volcano of Emikusi reaching 3,400 meters above sea level. To the west, in southern Algeria, the Hogar Mountains rise more than 2,500 meters into the warm, dry air. These quiet ranges are the geological skeleton of the Sahara. The Sahara is not made entirely of sand. In fact, only about a quarter of its surface is covered by the great sand seas that we usually picture. The rest is made of rocky plateaus called hamadas, of vast stony plains called regs, of dry valleys called wadis, and of the volcanic uplands of the central mountains. Each one of these has its own quiet character, its own patient way of being. Rain is very rare across the Sahara. Most parts of the desert receive less than 100 millimeters of rainfall in an entire year. In some places, no rain falls for many years in a row. The air is dry and the warm sun shines almost every day. The deepest interior of the Sahara is one of the most arid landscapes anywhere on the surface of our planet. The temperature in the central Sahara can be extreme during the day. In summer, the air can rise above 50 degrees Celsius, and the sand itself can become hotter still. The town of Azizia in Libya recorded what was for a long time the warmest air temperature ever measured anywhere on Earth. Yet at night, especially in winter, the same desert can fall close to freezing. The sand cools quickly under a clear sky. Very little vegetation grows across the open Sahara. Where the desert is at its driest, only a few hardy plants can survive. The acacia tree, with its thorny branches and tiny leaves, can take root near a dry wadi. The date palm grows wherever a hidden spring lifts water close to the surface. Saxaul shrubs, tamarisks, and small grasses appear in places where the wind drops moisture from passing clouds. Despite the dryness, the Sahara is not lifeless. Quiet animals make their long patient living in the warm sand. Fennec foxes hunt by night. Addax antelopes wander between water sources that may be hundreds of kilometers apart. Saharan cheetahs cross the open dunes, lighter in color than their cousins on the savanna. Reptiles and insects move with the warmth of the sun. The wind is the great patient sculptor of the Sahara. Every season, the warm air masses move in long, predictable patterns across the desert. In winter, the harmattan blows from the northeast, lifting fine dust high into the atmosphere. In summer, warm air flows the other way, drawing in moisture from the south. The wind has been shaping the dunes for many thousands of patient years. Saharan dust crosses entire oceans. Each year, the harmattan winds carry tiny particles of red, iron-rich silt high into the air. The dust drifts west across the Atlantic, where some of it falls into the sea, and some of it reaches the rainforests of South America. The mineral-rich dust quietly fertilizes the Amazon basin from many thousands of kilometers away. The bedrock beneath the Sahara is far older than the desert itself. In some places, the underlying rocks are more than 2 billion years old, formed long before the continents had taken their modern shape. The sand on the surface, by contrast, is a recent visitor, a thin, warm blanket spread over a much deeper geological past. The Sahara has not always been a desert. Across long stretches of geological time, the climate of northern Africa has changed many times. Periods of dryness and periods of greenness have alternated, each one lasting many thousands of years. The current dry period began roughly 5,000 years ago. Before that, the Sahara was green and full of lakes. In ancient times, when the Sahara was still green, herds of animals and small bands of humans lived across the central regions. Cave paintings on the cliffs of the Tassili Plateau in Algeria show giraffes, elephants, and hippopotamuses, all of them painted by hands that knew the desert as a fertile homeland. Slowly, as the rains failed, those creatures and those people drifted toward the rivers. The boundary of the Sahara is not a fixed line on the map. Each year, the desert breathes slightly. In dry seasons, it expands a few kilometers southward, drying out the edges of the Sahel. In wetter seasons, the green pushes northward. Over decades and centuries, this slow, patient breath has shifted villages and entire ways of life. To stand in the middle of the deep Sahara is to feel the size of the planet. Nothing breaks the horizon. Nothing reflects the warm sun. The wind moves softly across the surface of the sand. The distant mountains are too far away to see. The patient silence stretches in every direction. It is one of the quietest landscapes anywhere on Earth. The Sahara has always been at the center of long stories of human movement. Trade caravans crossed it for many centuries, carrying salt, gold, ivory, and slow news between the Mediterranean coast and the river kingdoms of the Niger and the Nile. The names of the caravan towns, Timbuktu, Gadames, Murzuk, Siwa, still carry the patient warmth of that long history. Tonight the Sahara still holds all of these things at once: the modern dryness and the ancient greenness, the empty dunes and the small green oases, the silent rocks and the slow stories of those who have crossed them. We will spend the rest of tonight gently visiting many parts of this great patient desert. Among all the desert surfaces of the Sahara, the most famous are the great sand seas. The Arabic word for them is erg. An erg is not a single dune, nor a small patch of sand. It is a vast region, sometimes hundreds of kilometers across, where the entire landscape is made of moving sand. The largest ergs of the Sahara are bigger than many countries. The Grand Erg Oriental, in eastern Algeria and western Tunisia, covers an area of about 190,000 square kilometers. The Grand Erg Occidental, just to its west, is somewhat smaller but no less remarkable. The Erg of Bilma in Niger, the Erg of Merzouk in Libya, and the Erg of Idihan in Algeria are all immense rolling fields of warm sand. Although deserts cover 1/3 of all the land on Earth, true sand sea ergs make up only a small portion of that. They form only where particular conditions come together: a steady supply of fine sand, a flat or basin-shaped landscape, and patient winds that move in consistent directions for thousands of years. Where these meet, a sand sea slowly grows. A single grain of desert sand is small but particular. It is usually between 0.1 and 0.5 millimeters across. It is most often made of quartz, a hard mineral that resists weathering. Each grain has been rolled and bounced by the wind for a long time, and so its corners are rounded smooth. A close look at a single grain shows a tiny worn pebble of the desert. Dunes come in many quiet shapes. The crescent dune, called a barkhan, is shaped like a slow new moon, with its concave face turned away from the wind. The linear dune, called a saif, from the Arabic word for sword, runs in long parallel ridges across the land. The transverse dune lies across the prevailing wind like ripples on water frozen at a giant scale. The most remarkable of all dunes are the star dunes. A star dune has multiple long arms that radiate from a central peak in 3 or 4 or even 5 directions. Star dunes form where the wind blows from many directions across the year. They tend to stay in one place rather than migrate, and they can grow extraordinarily tall, sometimes more than 300 meters from base to peak. Most dunes are not still. They are slowly walking across the landscape. The wind picks up grains from the gentle windward slope, lifts them in tiny brief flights, and drops them on the steeper face on the other side. Through this patient process called saltation, the entire dune drifts forward, perhaps 10 to 20 meters in a single year. The downwind side of a sand dune always rests at the same particular angle. As more sand falls onto the steep face, it slides down in small, soft avalanches until the slope settles. The exact angle is about 33 to 34 degrees, called the angle of repose for dry sand. Every dune in the world, no matter how large, settles into this same patient angle. Dunes can sing. In some sand seas of the Sahara, when the wind is right and the air is dry, a moving slip face produces a deep, low humming sound. The sound has been described as a distant choir or as the roll of a soft drum. Travelers have heard the singing dunes for centuries. It is caused by countless grains rubbing together as they slide together down the slope. Within an erg, the dunes are arranged in patterns that repeat across many scales. The smallest ripples on the surface, only a few centimeters across, mirror the shape of the larger meter-scale ripples beside them, which mirror the shape of the dune itself, which mirrors the shape of the larger dune cluster. The wind paints the same patient curve at every side. Some sand seas are bordered by sharper edges, where the dunes run up against rock plateaus or ancient lake beds. At these boundaries, the sand piles in tall, warm walls before the wind gathers it again and drives it on. From above, the boundary looks almost like a coast, a patient golden tide meeting the older shore of stone. Inside a great erg, after the sun goes down, the sand cools quickly. In a few hours, the same surface that was hot enough to burn bare feet falls to the temperature of cool stone. By the time the stars are bright overhead, the dunes are quietly cold. Animals emerge from their burrows to use the gentle chill of the night. The morning sun returns slowly. As it touches the eastern face of each dune, a warm line of light appears, and the warm tones of golden ochre, soft cream, and pale rose all begin to glow on the surface. For a few quiet minutes, the entire erg seems to wake up at once. Long shadows stretch across every ridge. The deepest part of an erg can be very disorienting for travelers. Without distant mountains for reference, every dune begins to look the same. The horizon becomes a slow, rolling repetition of warm gold curves. Caravans rely on stars at night and on slow, patient memory by day. A small mistake in direction can take many hours to correct. Beneath the surface of the dunes, the sand is layered. Older layers deposited in earlier wind seasons are slightly different in color and texture from the newer layers above. When a section of dune is cut open by erosion, these layers reveal a quiet history, a record of the wind, written one thin, patient line at a time. Even in the middle of a vast erg, life occasionally appears. A small footprint crosses a slip face, perhaps a fennec or a sand viper. A scarab beetle leaves a thin trail along a ripple. After a windless night, the surface of the dune is briefly written upon by the gentle creatures that live among the sand. From a great height, the largest ergs of the Sahara look like calm oceans. The dunes form long parallel patterns, like still waves frozen in time. Each ridge runs in the same direction, shaped by the prevailing wind across centuries. The whole sea of sand seems to flow slowly and patiently across the warm continent. From the rolling sand seas, we now move gently to a different kind of desert surface. Across the Sahara and many other dry regions of the world, vast areas are not covered by sand at all. Instead, they are flat, broad plateaus of warm bedrock, polished and scrubbed clean by the wind. The Arabic word for these stone plateaus is hamada, meaning the bare or unfruitful ground. A hamada is the result of patient erosion across many thousands of years. The wind, carrying its endless cargo of fine sand, has acted as a slow, natural sandpaper. It has stripped away every loose particle, leaving only the harder bedrock behind. Year after year, age after age, the surface has been quietly worn smooth. The Hamada du Dra in Morocco is one of the largest of these flat plateaus. It stretches across hundreds of square kilometers of dark, warm rock. The Hamada el Homra in Libya takes its name from the deep red color of its stones. The Hamada du Tinhert in Algeria is famous for the layered sandstone that gives its surface a soft, gentle texture. Closely related to the Hamada is the Reg. A reg is a desert pavement made of countless small dark pebbles, all of them resting on a sandy or silty ground. The wind has blown away the lighter dust over many ages, leaving behind a thin, patient mosaic of stones. From above, a reg looks almost like a smooth dark mat spread across the land. Each pebble in a desert pavement has often been polished on its top side and painted slowly with a natural varnish. The polish comes from the tiny grains of wind-blown sand that have struck the pebble countless times. The varnish is a thin, dark coating of iron and manganese oxides that builds up over many thousands of years. Every pebble carries a small, dark, patient record. Above the broad, flat plateaus rise stranger formations called yardangs. A yardang is a long, thin ridge of rock, shaped by the wind into a slow, streamlined form. The harder layers of stone resist erosion, while the softer layers around them are carried away. What remains is a quiet stone arrow lying along the prevailing wind direction. The Tassili Niger Plateau in southeastern Algeria is one of the most beautiful of the great hamadas. Its sandstone has been carved by wind and rare rains into towers, arches, narrow corridors, and broad open chambers. The name Tassili means plateau of rivers, a patient memory of the long ago wetter times when streams ran down its sandstone cliffs. Inside the rock shelters of Tassili are some of the oldest paintings in the world. Many of them are between 6,000 and 10,000 years old. They show running cattle, tall, slender people, hippopotamuses, and giraffes. They are a quiet record of a Sahara that was once green, painted on stone walls when the wind blew gentler and the rains still came. The Enadi Plateau in northeastern Chad is another great sandstone hamada. Its towering rock walls and natural archways were carved over many millions of years. Beneath some of its overhangs, small permanent pools of water remain even through the driest summers. Crocodiles still live in the deepest of these pools, quiet survivors from a long ago wetter time. In the central Sahara, the Tibesti and Hogar volcanic uplands form a different kind of stone country. There, dark basalt rock covers wide stretches of land. Cinder cones rise gently above the surrounding plain. Long-cooled lava flows run for many kilometers as smooth, dark, warm fields. The volcanoes have been quiet for many thousands of years, but the land remembers them. Wind-eroded mushroom rocks rise from many hamadas. Over time, the lower part of a freestanding pillar of stone is sandblasted more strongly than the upper part. The sandblasting wind moves close to the ground. Slowly, the lower stone becomes thinner, while the upper part keeps its width. The result is a patient stone mushroom in the middle of a flat plain. Some plateaus are pierced by deep, narrow canyons cut in long ago wetter times. The canyons are now mostly dry, but their walls still show the layered rock that shaped them. Walking inside a desert canyon, the warm sun is suddenly distant and the air becomes cooler. The patient sound of the wind echoes against tall, warm sandstone walls. Mesa and butte formations also rise from the hamada surface. A mesa is a flat-topped hill, broader than it is tall. A butte is a smaller, taller version, often with steep sides on every face. These formations are the gentle remains of older plateaus that have eroded away around them. The flat top of each one is a small, patient survivor of an ancient land surface. The surface of a hamada is often covered with shallow lichens. Even in this dry, warm country, tiny patient organisms cling to the rock. They look like soft green or gray or pale orange patches very thin against the stone. They live by drawing the small amount of dew that condenses on the rock during the cool desert nights. The hamada is a place where time becomes very slow. The same stones have been sitting in the same patient positions for thousands or millions of years. The wind moves over them grain by grain. The temperature shifts each day from warm to cool to warm again. Nothing seems to change, and yet every century, just a little more rock is taken away. Where a hamada meets a sand sea, the meeting is quiet but distinct. The dunes pile up against the harder rock and slowly creep over its edge. Some dunes stop at the boundary, others spill across. The result is a soft, warm coast where stone and sand share the same gentle horizon. Tonight, the hamadas of the Sahara continue their slow, patient existence. The wind passes over them. The stones rest. The lichens drink the dew. The mesas keep their flat, warm tops. They are among the oldest visible surfaces on Earth, calm and steady beneath the slow movement of the desert sky. Crossing a desert today, you sometimes step into a long, dry channel. Its bed is paved with smooth pebbles, softly polished by water that no longer comes. Its banks are gentle, low cliffs, cut clearly into the surrounding stone. The Arabic word for such a channel is Wadi. It is the patient memory of an old river, kept by the desert in stone. Wadis are common across every dry region of our planet. Many of them are very old. Their channels were cut during the last great wet phase more than 5,000 years ago, when streams flowed across what is now Sahara. Some are even older, dating back to the African humid periods of long before that. Each carries a slow memory of a different climate. Most wadis are dry for most of the year. Some carry water for only a few days each summer. A few never carry water in living memory at all. But when the rain does come, perhaps once in 5 or 10 years, the dry channel suddenly fills with a fast, warm, muddy flow. Within hours, the wadi runs as a real desert river again. These rare floods are called flash floods. They can move very quickly down narrow channels. The water carries gravel, soil, and small stones along with it. After a few hours, the flow slows, the water seeps into the warm sand, and within a single day the wadi is dry again. Yet during that brief flood, it is one of the most active places in the desert. Because wadis sometimes carry water, they are the natural pathways through which life moves through the desert. Acacia trees often grow along their banks, sending their roots deep into the sand to reach the moisture below. Tamarisks and small bushes thrive where the channel widens. After a flood, fresh green grass briefly appeared. Animals follow wadis as well. Gazelles graze along their edges. Birds rest in the shade of the bank. Even insects gather where the moisture is slightly higher. From the air, the entire dry wadi network looks like a quiet vein system spread across the warm continent, silent most of the time, but never entirely lifeless. In some wadis, the channel is wide and gentle. In others, it is narrow and deep, cut into the rock as a slot canyon. The slot wadis of the Sinai and the Arabian Peninsula are some of the most beautiful in the world. Their walls rise above the floor only a few meters apart. The light reaches the bottom only for a brief moment each day. Wadi al-Hitan in the western desert of Egypt, holds a remarkable record of ancient life. Within its sandstone layers are the fossil bones of early whales, animals that lived more than 30 million years ago, when the Sahara was a shallow, warm sea. Today, the same place is a dry valley, with quiet whale skeletons resting beneath the warm desert sun. Wadi Rum, in southern Jordan, is famous for its sandstone walls that rise hundreds of meters above the broad sandy floor. The valley between them is wide and gentle. Bedouin tribes have lived in the wadi for many generations. Their dark goat hair tents still rise from the warm sand at sunset against the deep red walls of the canyon. Many oasis villages of the Sahara are built along wadis. Even when the surface of the wadi is dry, water can often be found a short distance below the sand. Wells dug into the wadi bed reach this hidden water. Date palms and small gardens grow along the banks. The patient river beneath the surface keeps the village alive. The sediment of a wadi tells a slow story. When you cut into the bank, you see thin layers of gravel, silt, and sand stacked one on top of the other. Each layer is a single quiet flood from a single quiet ancient day. By counting and dating the layers, geologists read the climate of the desert backward through time. In some places, the bed of a wadi is paved with ancient mud cracks, the dry remains of small temporary pools. The polygonal pattern of cracks repeats across the surface in a quiet geometry. Each polygon is a small flat tile, edge to edge with its neighbors, all of them lying in the warm sun. The wind sometimes shapes wadi walls into smooth flutes and grooves called fluting. Over many years, the air running along a stone face carves it into long vertical stripes. The walls of a fluted wadi look like the pleats of a curtain hanging in stone. The pattern is slow, regular, and peaceful. Travelers across the desert have always used wadis as routes. A wadi often connects oases that lie along its course. It offers shade, occasional water, and a clear path through otherwise difficult country. Many ancient caravan routes followed wadi systems for thousands of kilometers, from one quiet green dot to the next. After the rare desert rains, a wadi briefly becomes a different place. The smell of damp earth rises into the warm air. Tiny green shoots appear on the banks. Insects emerge from cracks. Birds visit the new puddles. Within a week, most of the green will have faded again, but for a short moment, the dry channel feels like a soft living river. The slow, patient cycle of wadi life, long dryness, brief flood, longer dryness, has continued for many tens of thousands of years. The wind has not erased the channels. The rare rains keep them alive. Each wadi is a small reminder that the desert was once wetter and may, in cycles long beyond human time, become wetter again. Tonight, the wadis of the great deserts are quietly waiting. Their pebbles are dry. Their banks are warm from the long day. Their hidden water rests just beneath the surface, ready for the next rare rain. Many small creatures sleep in the cool shadow of their walls, and the patient channels themselves remember water that has not flowed in 100 years. In the long, dry expanse of the desert, every now and then the land softens into a small green gathering. Date palms rise from the sand. A still, warm pool reflects the sky. Birds rest in the shade of the trees. This quiet green dot, surrounded by warm dunes, is called an oasis. It is one of the most patient and welcoming places on the planet. Oases form where underground water rises close enough to the surface for plants to reach it. The water itself often comes from rain that fell many thousands of years ago when the region was wetter. It traveled slowly through layers of porous rock, deeper and deeper, until it found a channel back toward the light. This very old water is sometimes called fossil water. Beneath the eastern Sahara lies one of the largest collections of fossil water on Earth. It is called the Nubian Sandstone Aquifer System. It stretches under Egypt, Libya, Chad, and Sudan, and holds many hundreds of thousands of cubic kilometers of patient water. The springs of the Sahara's eastern oases all draw from this same vast, slow reservoir. The Siwa Oasis in western Egypt is one of the most famous of all the Saharan oases. Its salt lakes are surrounded by groves of date palms and olive trees. Mud brick houses rest in the warm shade. Ancient temples sit at the edges of the depression. The whole place lies many tens of meters below sea level in a quiet, patient bowl of sand. Other oases of the Egyptian Western Desert include Baharia, Farafra, Dakhla, and Karga. Each one sits in its own small green depression. Each one is bordered by warm cliffs of pale stone. Each one supports its own date palm groves, its own ancient wells, its own slow human communities, all of them drinking from the same hidden water far below. In Tunisia, the oases of Tozeur and Nefta lie at the edge of the Chat el Djerid, a great salt lake bed that becomes a shallow, shimmering mirror after the rare rains. Date palms grow in long, quiet groves along the edge of the salt flats. The contrast between the white salt and the dark green palms is one of the gentle wonders of the southern Sahara. Some oases are fed by natural springs that rise on their own. Others rely on wells dug carefully by hand, generation after generation. In southern Algeria and southern Iran, ancient underground irrigation tunnels called fagaras or qanats carry water from distant cliffs to the gardens of the oasis by gentle gravity and patient design. A fagara begins at a hillside where water-bearing rock lies near the surface. From there, a long sloping tunnel is dug horizontally back into the earth, sometimes for many kilometers. Vertical shafts at intervals along its length provide air and a way to remove the soil. The water flows quietly along the slope, all the way to the gardens of the village below. Inside an oasis, the air is always slightly cooler than outside. The shade of the date palms holds the heat at bay during the day. The pool of water adds a soft humidity to the warm, dry breeze. Birds rest in the upper canopy. Small lizards sun themselves on warm stones at the pool's edge. Beneath the date palms, oasis farmers grow many other plants. Citrus trees thrive in the gentle shade. Small wheat fields, vegetables, and herbs grow in the cooler microclimate. This kind of layered cultivation is sometimes called a three-story garden: palms above, fruit trees in the middle, and vegetables below. It uses every patient meter of moist ground. Many oases were once important stops along the long caravan trade routes. A traveling caravan could rest, water its camels, repair its loads, and gather news at the oasis before continuing into the empty desert. Some oases became wealthy trade towns over time. Others remained quiet, small villages for many centuries, their lives tied to the patient turning of the season. The Saharan oases of Mauritania include Chinguetti, where the old library still holds many ancient handwritten manuscripts. Some of them are more than 700 years old. Their pages still rest in dry, warm storage, watched over by the descendants of the original collectors. The patient knowledge of many generations is gathered there at the edge of the dunes. In Niger, The small oasis of Bilma sits at the foot of a long line of dunes. Its salt mines have been worked since long before the modern era. Once a year, large camel caravans called azalai still arrive there to load slabs of salt and carry them across the desert to faraway markets. The slow trade has continued for centuries. Some oases shelter old religious sites. The oasis of Ogala in Libya has small mosques whose walls have been smoothed by the wind for hundreds of years. The oasis of Gadames sits at the meeting point of three modern countries, with quiet covered streets and ancient mud brick towers that keep the inside cool through the warmest days. In recent decades, modern wells have been drilled into the deep aquifers below several major Saharan oases. These wells can produce a great deal of water in a short time. They have allowed new agriculture and new towns to grow, but the fossil water below is not being replaced quickly, and its careful, slow use is one of the patient questions of the desert today. Animals find the oases as well. Migrating birds often stop at oasis pools as they travel between Europe and the southern continent. Gazelles drink quietly in the cool early hours. Foxes and small mammals come close at night. The oasis is one of the few places in the desert where many kinds of life gather in the same small patient circle. Tonight, the oases of the great deserts continue their long, quiet existence. Their water rises slowly from the deep aquifers. Their date palms move gently in the warm evening breeze. Their pools reflect the stars after dark. They are small green islands of life, surrounded on every side by the long, patient sea of warm sand. At the heart of every Saharan oasis stands the date palm. Its scientific name is Phoenix dactylifera. It is one of the oldest cultivated trees in human history. People have been growing date palms for at least 5,000 years, perhaps for as long as 7,000. Its long, quiet relationship with the dry, warm world is among the most patient of any tree. A date palm is not a true tree in the strictest sense. It is a giant grass, more closely related to bamboo than to oaks or pines. Its trunk does not grow rings. Instead, the palm grows by adding new fronds at the top year after year. The old fronds eventually fall away, leaving a quiet diamond pattern of scars all the way down the trunk. Date palms can live to be more than 100 years old. Some particularly patient trees have been cared for by many generations of the same family. Each tree begins life as a small offshoot at the base of an older palm. The offshoot is gently separated, planted in its own warm, sandy ground, and slowly raised over many years until it reaches full height. The date palm is dioecious, meaning that male and female flowers grow on different trees. The male trees produce pollen but no fruit. The female trees produce the dates, but only if they are pollinated in the wild. The wind carries the pollen from male trees to female trees. In oasis gardens, farmers do this by hand, climbing each tree at the right moment in the spring. Hand pollination has been practiced in the Sahara and the Middle East for many thousands of years. A single male tree provides pollen for as many as 50 female trees. The pollen is gathered carefully, dried, and then placed inside the open female flowers using a slow, patient hand. The technique has been passed quietly from father to son for many generations. Once pollinated, each female flower cluster becomes a long, quiet bunch of green dates. As the summer passes, the dates ripen slowly, changing color from pale yellow or red to deeper amber, and finally to soft, warm brown. A single tall palm can produce 100 kilograms of fruit in a single year, A whole grove can feed many families through the patient winter. Among the many varieties of dates in the world, a few are especially well known. The medjool date, large and soft and very sweet, is sometimes called the king of dates. The Deglet Nur, slimmer and golden, is the most widely traded variety. The Barhi date can be eaten when still pale yellow, before it has fully ripened. The Halawi is small, soft, and gently sweet. A ripe date is roughly 70% sugar. This very high sugar content gives the date its remarkable patience. Once dried, dates can be stored for many months without spoiling, even in warm conditions. They were one of the most reliable foods of the long caravan journeys, easy to carry and rich in calm, slow energy. Bedouin and Saharan tradition has a saying about the date palm, that it grows best with its feet in cool water and its head in warm fire. Its roots reach deep into the moist sand near the water table. Its crown stands high in the hottest direct sun. Few other trees can hold both extremes at once. In an oasis garden, every part of the date palm is used. The fronds are woven into mats, baskets, ropes, and roofs. The fibers from the trunk are used as a soft natural padding. The wood, when a tree finally falls, is used in building. The seeds are sometimes ground for animal feed. The patient tree provides for almost every quiet domestic need. Beneath the date palms, the temperature can be many degrees cooler than out in the open desert. The dense canopy of fronds blocks much of the warm sun. The moisture from the irrigation channels rises gently into the cooler air. Walking into a palm grove from the open dunes is like stepping into another, quieter climate. Date palms grow naturally in many of the world's warm, dry regions. They thrive across North Africa, the Arabian Peninsula, southern Iran, parts of Pakistan, and the warmer corners of southern Europe. They have also been planted in California, in northern Mexico, and in southern Australia. Wherever the climate is dry enough and warm enough, the patient palm finds a home. In some Saharan oases, the date harvest is a community event. Whole families gather under the trees during the late summer or early autumn. Climbers ascend each palm with a rope around the trunk. The clusters are cut carefully and lowered to the ground in cloth slings. The dates are then sorted, dried, and stored in cool shade. Although the date palm is patient, it is not invulnerable. A small beetle called the red palm weevil has spread across many palm-growing regions in recent decades. It bores into the trunk and slowly hollows it out from inside. Many oasis communities now watch their trees carefully, looking for the small, soft signs of infestation. Some date palms have entered legend. In the Egyptian oasis of Bahariya, certain very old palms are said to have stood since the days of the pharaohs. In Saudi Arabia, individual palm trees have been carefully named and recorded for centuries. Each old tree is regarded as a small witness to the history of its quiet, warm garden. In Islamic tradition, the date palm holds a place of special quiet honor. It is mentioned many times in the holy texts as a sign of patience and provision. Many Muslims still break the fast of Ramadan with a single ripe date, in keeping with a very old custom. The simple, gentle tree is woven deep into many human stories. Tonight, the date palms of the great oases continue their long, quiet existence. Their roots are drawing slow water from the cool aquifers. Their fronds are swaying gently in the warm night breeze. Their fruit is ripening slowly under the desert stars. The patient trees rest at the soft heart of every desert village, exactly as they have for thousands of years. across the central and southern Sahara, in the lands that touch Algeria, Libya, Mali, Niger, and Burkina Faso, lives a people who have called the desert home for many quiet generations. They are the Tuareg. Their own name for themselves is Kel Tamashek, the people of the Tamashek language. They are one of the oldest patient inhabitants of the deep desert. The Tuareg are part of the larger Berber-speaking world of North Africa. Their language, Tamashek, has its own ancient writing system called Tifinagh. The Tifinagh script uses simple geometric letters often carved into rocks at desert resting places. Some of the oldest Tifinagh inscriptions are more than 2,000 years old. One of the most recognizable features of Tuareg life is the men's veil. Adult Tuareg men wear a long indigo-dyed cloth, several meters long, wrapped many times around the head and face. Only the eyes are usually visible. The veil is called a tegelmust. It protects the face from sun, wind, and blowing sand. It is also worn as a sign of dignity. The deep blue color of the indigo cloth often transfers slightly onto the wearer's skin over many years. This gentle blue tint has given the Tuareg one of their old nicknames in European writings, the blue people of the Sahara. The dye is patient and persistent. It carries a softness of color that no other fabric in the desert quite shares.
Tuareg society is organized in a way that is unusual in the wider region. It is matrilineal. This means that family identity, household possessions, and social status pass through the female line. Women hold the family's tents, the family's animals, and the family's stories. A man marries into the household of his wife. The social fabric rests on a long, quiet female center.
The traditional Tuareg dwelling is a low tent made of dyed goat hide or woven cloth. The tent is held up by carved wooden poles. Inside, the floor is covered with woven mats. Bags of food, leather chests of belongings, and a small fire complete the household. The whole tent can be packed onto a single camel and moved to a new place when the season changes. Tuareg life has long been built around the camel and the long caravan. For many centuries, Tuareg traders moved goods across the deep Sahara, salt from the northern oases, gold and ivory from the southern lands, and slow news in every direction. The trans-Saharan trade lasted for more than 1,000 years. Tuareg families were at the patient center of much of it. The Hoggar Mountains in southern Algeria are one of the spiritual hearts of Tuareg country. There, in the deep volcanic uplands, the cool air gathers around tall stone towers. The town of Tamanrasset is one of the modern centers of Tuareg cultural life. From the surrounding mountains, the deep silence of the Sahara feels especially close. In the desert of Niger, the Air Mountains hold another major Tuareg homeland. The town of Agadez, at the edge of the Air, has been a Tuareg center for many hundreds of years. Its old mud brick mosque, with its tall, straight minaret, is one of the most striking traditional buildings of West Africa. It rises quietly above the warm streets of the old town. Tuareg music holds many quiet stories. One of the most famous traditional instruments is the imzad, a single-stringed bowed fiddle played by women. Another is the tende, a small drum made from a wooden mortar with a goatskin top. Songs are usually slow and patient, often built around long, sustained melodies that echo the long horizons of the Tuareg land. Tuareg jewelry and metalwork are particularly fine. The traditional Tuareg cross of Agadez is a flat silver pendant with a square center and 5 extending arms. Each town has historically produced its own slight variation of the cross design, the patient silversmiths who make them learn their craft for many years before they are trusted with the simplest piece. The Tuareg tea ceremony is one of the daily quiet rituals of the desert. Strong green tea is brewed 3 times in the same small pot, with sugar and sometimes mint. Each cup is poured from a deliberate height, creating a soft foam on top. The first cup is bitter, the second is gentle, and the third is sweet. Each one takes patient time. In Tuareg tradition, hospitality is one of the highest values. A guest who arrives at a tent, even a stranger, is given water, food, and a place to rest before any questions are asked about who they are or where they have come from. The custom comes from a quiet, practical wisdom of the desert. In a place of long, warm distances, kindness keeps everyone alive. One of the most legendary figures of Tuareg history is Tin Hinan, a woman remembered as the founding ancestor of the Hogar Tuareg. According to long oral tradition, she came from the north many centuries ago, settled at the foot of a great rock outcrop, and gave rise to many of the major Tuareg clans. A large stone tomb attributed to her has been found in southern Algeria. In modern times, the Tuareg have faced many quiet difficulties. Borders drawn during the colonial era cut across their traditional lands. Several long droughts have diminished the herds that once supported their nomadic life. Some Tuareg families have moved into cities, others continue the older patterns, moving seasonally between pasture, salt route, and oasis. Despite these changes, much of the slow heart of Tuareg life continues. Music is played, tea is brewed, the tagelmust is wrapped each morning, camels are watered and saddled. The patient long horizons of the Sahara still call families away from the towns and back into the open, warm country, exactly as they always have. Tonight, somewhere in the deep Sahara, a Tuareg family is brewing tea by a small, quiet fire. The kettle steams softly. The dunes rest beneath the rising stars. A camel sleeps a short distance away, knees folded into the warm sand. The slow, patient world of the Tuareg continues exactly as it has for many quiet generations. Of all the patient creatures that have shared the great deserts with human beings, none have been more important than the camel. For thousands of years, the camel has carried people, cargo, and slow news across landscapes where no other large animal could survive. The relationship between human and camel is one of the deepest partnerships in the long history of the warm, dry world. There are 2 main species of camel in the world today. The dromedary with a single hump lives across the Sahara, the Middle East, and the dry edges of South Asia. The Bactrian camel with 2 humps lives in the colder steppes of Central Asia, where it can survive temperatures far below freezing. Together they represent the patient genius of camel evolution. Camels were domesticated long ago. The dromedary is thought to have been first tamed in the Arabian Peninsula at least 4,000 years ago, perhaps earlier. The Bactrian was tamed at roughly the same time across the high cold plains of Central Asia. Both species had wild ancestors that roamed dry lands for many thousands of years before that. The hump of a camel is not a water tank, it is a reservoir of fat. When food is scarce, the camel slowly draws on the energy stored in its hump. After a long journey, the hump may shrink and lean to one side. After several weeks of good grazing, it fills out again. The fat is a patient, slow battery for the warm, dry road. Camels can drink remarkable quantities of water in a single session. A thirsty camel may drink 100 liters or more in just a few minutes. The water is absorbed gently into the bloodstream and the body tissues, then released slowly over the days that follow. After a single deep drink, a working camel can travel many days without water again. The body of a camel is built for warm, efficient travel. Its long legs carry it high above the hot ground, where the air is slightly cooler. Its thick eyelashes shade its eyes. Its nostrils can close almost completely against blowing sand. A third clear eyelid sweeps debris from the eye without blocking vision. Each detail is the result of long, patient adaptation. The wide, soft feet of a camel are particularly remarkable. Each foot has 2 toes connected by a tough, leathery pad. As the camel walks, the foot spreads on contact with the ground and grips the soft sand without sinking. This patient design allows a heavy animal to travel long distances over loose dunes without difficulty. Camels can lose a quarter of their body water without harm. Most other large mammals would die from such dehydration. The camel's red blood cells are oval rather than round, which allows them to keep flowing even when the blood becomes thicker. Its kidneys produce urine that is twice as concentrated as seawater. Its digestive system extracts every patient drop of moisture from its food. Camels regulate their body temperature in an unusual way. Most mammals keep their internal temperature very constant. The camel allows its body to warm by several degrees during the long hot day and then cools by the same amount overnight. By postponing its cooling until the cool night, it saves a great deal of water that would otherwise be lost through sweating. A working dromedary can carry a load of 200 kilograms or more. Trade caravans of the medieval Sahara sometimes consisted of more than 200 camels traveling together. Each camel carried its own pack. The whole long line of animals stretched for a kilometer or more across the warm sand. The slow, steady movement of such a caravan was a quiet, patient marvel. Camels can live for 40 to 50 years in the wild and in domestic care. A single camel often shares its long working life with a single human family. The camel learns the names of its humans. It recognizes voices. It carries its memories of routes, water sources, and patient companions. Some Bedouin and Tuareg families have written gentle elegies for particularly faithful camels. In Tuareg and Bedouin cultures, camels have many names. Different words describe different ages, different colors, different temperaments, and different gaits. A young female camel is called by one word, an older male by another, a particularly fast-riding camel by a third. The richness of the vocabulary reflects the long, quiet importance of these patient companions. Camels communicate with one another in a low, gentle vocabulary of grunts, soft moans, and quiet rumbles. A patient mother camel calls softly to her young calf when they are separated. A working camel sometimes complains gently as its load is added. The desert at night is often full of these soft sounds, drifting from one resting animal to another. Camel milk has been one of the staple foods of desert peoples for many centuries. It is rich in vitamin C and gentler on the stomach than cow's milk. Tuareg and Bedouin families drink it fresh, ferment it into a soft yogurt, and dry it for travel. A single milking she-camel can provide enough milk to support a small family through long stretches of dry season. Camel races are still held in many parts of the Sahara, the Arabian Peninsula, and Central Asia. The fastest racing camels can run at 40 kilometers per hour over short distances. Over longer distances, they settle into a steady, patient gait that can cover 100 kilometers in a single day. The long, elegant motion of a galloping camel is one of the calm wonders of the warm world. Modern roads, trucks, and air travel have replaced many of the old caravan routes. Yet camels are still important across much of the dry world. They are bred for milk in Saudi Arabia and Pakistan. They are used for transport in remote oases. They are kept for tradition and for love. The patient long-eared face of the camel still rests at the center of many quiet desert evenings. Tonight, across the warm sand seas of the Sahara and the cold steppes of Central Asia, many thousands of camels are quietly resting. Some sleep with their long necks curled against their humps. Some slowly chew the long, thin acacia leaves they gathered earlier. Some look out across the moonlit dunes, calm and patient, exactly as their ancestors have done for many thousands of years. Of all the long trades that have crossed the great deserts of the world, perhaps the most patient is the trade in salt. For more than 1,000 years, long caravans of camels carried slabs of salt from the warm, dry mines of the deep Sahara to the cooler river towns of the south. These quiet roads have shaped much of the slow human history of West Africa. In the lands south of the Sahara, where the climate is warm and damp, salt does not occur naturally near the surface. It must be brought from far away. In the deep heart of the Sahara, by contrast, salt is plentiful. Ancient evaporated lakes have left behind thick, patient layers of pure salt, ready to be cut into slabs and carried south. One of the most famous of the Saharan salt mines is at Todeni in northern Mali. There, in a flat white basin in the middle of the open desert, miners have cut salt slabs by hand for many centuries. The slabs are about 1 meter long, somewhat narrower in width and several centimeters thick. Each slab weighs around 30 kilograms. Another famous Saharan salt source is at Bilma, in eastern Niger. The salt of Bilma is harvested from shallow brine pools that lie at the edge of a small oasis. The pools are filled with warm groundwater. Over weeks, the warm sun evaporates the water, leaving a thin layer of clean white salt on the bottom. The salt is then collected and pressed into round patient cakes. The salt from Bilma travels north on the back of a great patient caravan called the Azali. The word Azali itself means salt caravan, and the journey it describes has been the most important annual event of much of central Niger for centuries. Hundreds of camels gather in late autumn for the slow, patient walk that lies ahead. From Bilma, the salt caravans cross the Tenere Desert to the town of Agadez on the southern edge of the Air Mountains. The journey covers several hundred kilometers of warm sand and stone. There are no marked roads, no signposts, no shaded resting houses. The caravan walks slowly through the open country, day after day, navigating by stars and patient landmarks. The northern routes from Todeni go to the river town of Timbuktu on the southern edge of the Sahara. From there, the salt continues south by smaller caravans and by boats along the Great Niger River. By the time the salt reaches the markets of Mopti or Djenne, it has traveled more than 2,000 kilometers from the warm pan where it was first cut. The slow, patient time of a salt caravan is measured in weeks. The journey from Todeni to Timbuktu takes about 3 weeks each way. The journey from Bilma to Agadez takes about a week. The caravans travel slowly to conserve the strength of the camels. They rest during the warmest part of the day and walk during the cooler hours of the morning and evening. The trans-Saharan trade reached its peak many hundreds of years ago in the medieval era. At that time, salt and gold were exchanged in roughly equal weight at the markets of the southern Sahel towns. A camel load of salt could be traded for a small bag of gold. The patient, slow movement of these two simple things shaped the entire economy of West Africa. Timbuktu, in particular, became a great center of trade and learning during this period. Its markets were full of goods from across the Sahara and across the savannah. Its libraries held many thousands of handwritten manuscripts on theology, mathematics, astronomy, and medicine. The patient salt caravans were not only carrying minerals, they were also carrying news and knowledge. Each camel in a salt caravan typically carries 4 salt slabs. 2 are slung on each side of the saddle, balanced carefully so the load does not tilt. A single fully laden camel carries about 120 kilograms of salt across an entire caravan. This can amount to many tons of patient white cargo crossing the desert at the same time. The men who lead the salt caravans are usually Tuareg or related Saharan peoples. They learn the routes from older relatives across many years. Each leader knows which dunes to cross, which wadis to follow, which wells still hold water in dry seasons. A single misjudgment of route can cost the lives of camels and travelers alike. The leader's patient memory keeps the caravan safe. During the long crossing, the caravan stops at certain known wells. Some of these wells are very old, carved into the stone in earlier generations. Others are newer. Each well must be carefully cleaned, water drawn slowly with leather buckets, and every camel given enough drink to last until the next stop. A full watering can take many quiet hours. The salt itself is more than a flavoring. In the warm, humid lands of the southern Sahel, salt is essential for preserving meat and fish. Without it, food spoils quickly. Without preserved food, larger settlements cannot exist. The patient salt caravans, by simply carrying their slabs from the warm pans to the southern markets, have made many cities possible. Modern times have brought trucks, paved roads, and industrial sea salt to the markets that once depended on the caravans. Many of the older salt routes have quietly faded, yet in some places the slow tradition continues. The annual Bilma Agades Azalai still walks each year. A few caravans still cross from Todeni to Timbuktu. The patient roads have not entirely closed. The men and animals who walk these routes today carry the same patient knowledge as their ancestors. The same dunes are crossed, the same wells are visited, the same stars guide the same direction. Each caravan is a small living memory of a much older world, kept alive by the slow, steady steps of the camels. Tonight, somewhere on the long caravan road between the warm pan of Bilma and the green oasis of Agadez, a small group of camels and travelers is resting. The fire is low. The salt slabs are stacked carefully in the cool sand. The stars are bright. The desert is quiet. The patient road continues exactly as it has for so many calm centuries. Although the desert seems empty by day, it is full of patient, quiet life. Many small mammals make their long, warm living in the sand, in burrows, in the shade of acacia trees and along the edges of the wadis. Tonight, we will spend a gentle while visiting some of the most beautiful of them. We will begin with the smallest fox in the world. The Fennec fox lives across the Sahara and the dry edges of the Arabian Peninsula. Its scientific name is Vulpes zerda. An adult fennec weighs only about 1.5 kilograms. Its fur is cream-colored, soft pale beige, and almost the same shade as the sand it walks on. From a small distance, a still fennec is almost invisible against the warm dune. The most striking feature of the fennec is its enormous ears. They can measure 15 centimeters from base to tip, longer than the entire body of many smaller mammals. The ears help the fox in two important ways. They radiate excess heat away from the body, keeping the small fox cool in the warm air. They also catch the very faint sounds of insects and small prey moving beneath the sand. The fennec is mostly active at night. During the day, it rests in a deep burrow under a small dune or beneath the roots of an acacia tree. The burrow can be many meters long with several entrances. Inside, the temperature is gentle and stable, much cooler than the warm air above. The fox curls into a small calm ball and waits for the warm sun to fall. Fennecs hunt small insects, rodents, lizards, and birds. They also dig out roots and gather small fruits from acacia trees. Their large ears help them locate prey beneath the sand. They will often pause, listen carefully, then leap suddenly forward to catch a beetle or a small lizard hidden in the warm grain. Their movements are quick but light. Fennecs can survive without drinking surface water at all. They obtain almost all the moisture they need from the bodies of their prey, from the few small fruits they eat, and from the dew that condenses on plants and stones during cool desert nights. Their kidneys produce extremely concentrated urine, conserving every patient drop. They are perfectly built for the warm, dry world. Beyond the fennec, the Sahara is home to the addax, a patient white antelope of the deep dunes. Adult addaxes have long spiral horns and a soft cream-colored coat that turns nearly white in the warmest summers. The white color reflects the sun and helps the animal stay cool. The dark gray patch across the bridge of its nose is one of its most recognizable features. The addax is now critically endangered. Hunting and habitat loss have reduced its wild population to perhaps fewer than 100 individuals scattered across the deep desert. Conservation programs in Niger, Chad, and other nations are working slowly to protect what remains. Each surviving addax is a small patient witness to a much older Sahara. Another beautiful Saharan antelope is the scimitar-horned oryx. Its coat is white with reddish markings on the chest and face. Its horns curve gently backward in a long, graceful arc. The oryx was once common across the southern Sahara and the Sahel. By the late 20th century, it had become extinct in the wild, but careful reintroduction programs in Chad and Tunisia have begun to restore small herds. The Dorcas gazelle is one of the smallest and most graceful gazelles of the Saharan world. It can survive without drinking surface water for its entire life, getting all the moisture it needs from its food. Its sandy beige coat blends with the warm desert background. It moves in small family groups, walking patiently between scattered patches of grazing. The Saharan cheetah is one of the rarest large cats in the world. It is paler than the cheetah of the savanna, with smaller spots and a faintly strippier appearance on the lower legs. Fewer than 250 Saharan cheetahs are thought to remain in the wild, scattered across the deep desert from Niger to Algeria. They walk alone, mostly at night, hunting gazelles in the cool, gentle hours. The sand cat is a small, soft, sand-colored cat that lives across the Sahara, the Arabian Peninsula, and Central Asia. It is hardly larger than a domestic house cat. Its paws are heavily furred underneath, allowing it to walk on hot sand without burning its pads. Its ears are large and lie low along the side of its head, helping it remain unseen as it stalks across the open dunes. The jerboa is a small kangaroo-like rodent of the deep desert. It has tiny front legs and very long back legs that allow it to leap quickly across the warm sand in a series of soft hops. Its tail is long and tipped with a small white tuft. Several species of jerboa live across the Sahara, and they are among the most charming small mammals of the warm night. Up in the Rocky Mountains of the Central Sahara, the Barbary sheep, also called the Aoudad, lives across the hot, stony slopes. It has a thick, reddish-brown coat and long, curving horns. The Aoudad climbs the warm cliff faces with great patient skill. It can find pools of water hidden in cool, shaded gorges that few other animals could reach. The striped hyena is the only species of hyena that lives across the Sahara and into the Middle East. It is smaller than its African relatives, with a soft, pale coat marked by gentle, dark stripes. It is mainly a scavenger, feeding on the remains left by larger predators. It walks alone or in small family groups, mostly at night, with a quiet, patient gait. Many of the small mammals of the desert have one trait in common. They live in burrows. The burrow protects them from the warm sun, from the cold winter nights, and from larger predators. Some burrows are simple, others are extensive networks with multiple entrances and branching tunnels. Beneath the warm dunes, an entire quiet underground world exists. Tonight, the small mammals of the great deserts are quietly going about their patient lives. Fennecs are listening for beetles. Sandcats are stalking jerboas. Gazelles are resting in small groups. Addaxes are walking slowly across the deepest dunes. Each one is a small, soft presence in the long, warm silence of the desert night. Smaller still than the mammals, the reptiles and insects of the great deserts are perhaps the most numerous of the patient, quiet inhabitants. They are well suited to the warm, dry world. Their bodies hold moisture more efficiently. Their behavior follows the warmth of the sun. Many of them never need to drink water at all. Tonight, we will visit some of the gentlest and the most remarkable. The spiny-tailed lizard, called the dab in Arabic, is one of the larger reptiles of the Saharan world. It can grow nearly 70 centimeters long from nose to tail. Its tough, rough scales protect it from heat and from small predators. It feeds mostly on grasses, flowers, and seeds. It is one of the few mainly vegetarian lizards on Earth. The sandfish is a small lizard that swims through loose sand, the way a fish swims through water. Its body is smooth and pale, with tiny, strong limbs that fold against its sides as it dives below the surface. Once underground, it moves with gentle, rhythmic motions, hunting tiny insects in the cool sand below. It surfaces only briefly to breathe. The Saharan horned viper is a small, patient snake of the warm sand. Its name comes from the small horn-like scales above each eye. Its color is a soft, pale yellow sandy gold or warm cream, almost identical to the surrounding sand. The viper buries itself just below the surface with only its eyes and the tip of its head exposed. From this hidden place, it waits very quietly for prey. Several smaller species of viper live across the warm dunes, each adapted to its own particular habitat. The Saharan sand viper is even smaller, only 30 or 40 centimeters long. The desert horned viper is found across the Middle East as well. All of them rely on the patient art of stillness, remaining motionless until a small lizard or rodent comes within easy reach. Geckos make up another patient family of desert reptiles. The Saharan rock gecko clings to warm sandstone walls in the central mountains. The gecko's toe pads are covered with billions of tiny hairs called setae, each one no thicker than a strand of spider silk. Together, these hairs allow the gecko to walk along nearly any surface, even upside down on a smooth ceiling. Some lizards can change color slightly to match their surroundings. The Agama lizards, common across many parts of the warm Sahara, become a bright orange or blue during the breeding season. At other times, their color softens to match the warm rocks where they rest. The change is slow and patient, governed by the warm rhythms of light and temperature. Among the insects of the desert, the silver ant is one of the most remarkable. The Saharan silver ant, Cataglyphus bombycina, is famous for being one of the most heat-tolerant animals in the world. It forages on the surface of the sand at temperatures that would kill most insects within minutes. Its silver hair-like coating reflects sunlight, helping it stay slightly cool. The deathstalker scorpion is a small yellow scorpion of the Saharan and Middle Eastern world. It rarely grows larger than 5 or 6 centimeters from claws to tail tip. Its color is a soft pale yellow, almost the color of the warm sand. It hunts by night, mostly small insects and spiders. During the day, it rests under a stone or in a small burrow in the cool ground. Other species of scorpions live across every great desert of the world. The Saharan thick-tailed scorpion, the Arabian fat-tailed, and the Mongolian sand scorpion are all close relatives. Each one has the same patient, quiet body plan: 8 legs, 2 grasping claws, a long jointed tail with a small bulb of venom at the tip. Each one moves slowly, patient and calm in the cool night. Locusts are perhaps the most famous insects of the desert world. The desert locust, Schistocerca gregaria, lives across North Africa, the Middle East, and parts of South Asia. Most of the time it is solitary and harmless, but when conditions are right with warm rains and abundant grass, the locust enters a different patient phase. Vast swarms gather and travel together in long, quiet clouds. Dung beetles are another quiet presence in the warm desert. The beetle gathers a small ball of dung many times its own weight, then rolls it patiently across the warm sand to a chosen burrow. Some species use the polarized light of the moon as their navigation guide. The patient straight roll across the dunes, with the small dark beetle pushing the soft round cargo, is one of the calm wonders of the desert night. The antlion is a small, soft predator of the desert. The larva digs a careful conical pit in fine sand and waits at the bottom. When a small ant or insect tumbles into the pit, the antlion's hidden jaws emerge from below and catch the prey. After many quiet weeks of feeding, the larva pupates and emerges as a delicate adult that resembles a small dragonfly. Camel spiders, also called solifuges or wind scorpions, are not true spiders but a separate ancient group of arachnids. They are fast with small, powerful jaws. They are usually pale yellow or sandy beige. They hunt at night, eating insects, small lizards, and other small invertebrates. They are not dangerous to humans, though their patient, strange shape has earned them many gentle desert legends. Sand grouse are small, soft desert birds, somewhat related to pigeons. The males have a remarkable patient adaptation. Their belly feathers can absorb water and hold it. After flying many kilometers to a distant waterhole, the male wades briefly into the pool, soaking his belly. Then he flies home and his chicks gently drink the water from his feathers. Termites build small, soft mounds in some parts of the warm desert. Each mound is a tall, sandy hill, often a meter or more in height. Inside, the termite colony lives at a stable, cool temperature, regulated by carefully designed ventilation channels. Some mounds in the southern Sahara are decades old, slowly raised by the patient labor of countless tiny workers. Tonight, in the quiet, warm sand of the great deserts, countless patient small lives are gently going about their business. Vipers wait in the loose grain, geckos cling to walls, silver ants rest in their burrows, beetles roll their patient small balls across the moonlit dunes. The desert is never silent. It is full of soft, quiet life, almost too small to see. Across the great deserts, the wind is rarely entirely still. Most days, a soft, warm breeze passes gently across the dunes, but once or twice a season, the air gathers itself into something larger and quieter and slower at the same time. A great wall of warm dust rises on the horizon and walks across the land. The Arabic word for such a wall is haboob. A haboob can rise to many hundreds of meters in height. The leading edge looks like a tall, warm cliff of soft amber dust. Behind the wall, the air is thick and warm with suspended sand. Inside the wall itself, visibility drops to nearly nothing. The whole structure can be many kilometers wide and tens of kilometers long, all moving together at 30 or 40 kilometers per hour. Haboobs form when a strong downdraft of cool air falls from a distant thunderstorm and spreads quickly across the warm desert surface. As it moves, the cool air lifts fine, warm sand and dust into a tall front. The whole structure travels along the ground as long as the cool air is still flowing. When the cool air finally settles, the dust slowly falls back to the ground. Before the wall arrives at any given place, the wind first becomes still. Then the air begins to smell faintly of warm dust. The horizon takes on a soft amber color. Within a few minutes, the leading edge is overhead. The daylight dims to a warm orange, and visibility drops to a few meters. People and animals close their eyes and wait quietly for the wall to pass. Camels know exactly what to do when a sandstorm arrives. They lie down with their backs to the wind, fold their long legs under their bodies, and close their eyes and nostrils. Their thick eyelashes and closed nostrils keep the fine dust out. After the wall has passed, they shake themselves once and stand up calmly, often with a thin layer of warm dust still resting on their coat. The Tuareg veil, the tagal must, was originally designed for exactly this kind of weather. The long, warm cloth covers the face from below the eyes down to the neck. The eyes themselves are sometimes shielded with a cupped hand or with leather goggles. With the veil in place, even the warmest dust storm can be passed through with quiet, patient discomfort rather than real danger. Beyond the haboob, the deserts are home to a number of other named winds. The harmattan blows from the northeast across the Sahara during the winter months. It is dry and warm, and it carries fine dust very high into the atmosphere. The harmattan can darken the sky over much of West Africa for days at a time, softening the warmth of the sun into a gentle amber haze. The sirocco is another famous warm wind. It blows from the Sahara northward across the Mediterranean Sea, gathering moisture from the water as it travels. By the time it reaches Italy and southern Europe, it has become a warm, humid wind, sometimes carrying very faint pinkish dust from the deep desert. Roofs and windows in southern Europe sometimes show a soft, warm dust film after a sirocco. In the Atacama and other South American deserts, similar warm winds blow regularly. In Mongolia and northern China, the spring brings yellow dust storms that can travel as far as Korea and Japan. In Australia, the air basin sometimes generates dust walls that drift over Sydney. Across every continent with a great desert, the warm wind walks patiently in its own particular way. Sandstorms have shaped the desert landscape itself. The wind erodes the rocks slowly into the patient shapes we have already seen: the yardangs, the mushroom rocks, the smooth fluted walls of canyons. The wind also moves the dunes themselves across the warm continent. Without the wind, the desert would not look the way it does. The patient sandstorm is a kind of sculptor. The dust carried by Saharan storms travels remarkably far. Each year, vast quantities of warm Saharan silt are lifted high into the atmosphere by the Harmattan winds. The dust drifts west across the Atlantic Ocean. Some of it falls into the sea, some of it reaches the Caribbean, the Bahamas, and the southern United States. A small but important fraction reaches the Amazon rainforest. This Saharan dust is rich in iron, phosphorus, and other patient minerals. When it falls on the Amazon, it gently fertilizes the rainforest soil. Some scientists estimate that the productivity of the Amazon depends in part on the slow, steady delivery of warm Saharan dust from across the entire ocean. The wind that walks the desert also walks the rainforest in a long, calm partnership. Saharan dust also affects the climate. The high concentration of fine particles in the warm air can reflect a small amount of sunlight back into space. This gentle effect cools the lower atmosphere slightly. It can also reduce the formation of hurricanes in the Atlantic Ocean during certain seasons. The wind from the desert affects warm weather many thousands of kilometers away. Inside a real haboob, there is sometimes a quiet display of static electricity. The friction of countless dust particles rubbing together generates small, soft electrical charges. In some storms, faint blue arcs can appear briefly between rocks and metal. The Tuareg have long known about this phenomenon. They say that the desert itself sometimes makes a quiet, warm light of its own. After a haboob has passed, the desert is briefly transformed. A thin, warm layer of new fine dust rests on every surface. Tracks of recent travelers are erased. Dunes have shifted slightly. Small hidden seeds exposed to the air for the first time in years may begin slowly to grow. The patient, warm wall of dust has rearranged a small piece of the world. Some Saharan dust storms have been recorded for thousands of years. Ancient Egyptian texts describe them. The Bible mentions them. Greek, Roman, and medieval Arab writers all knew them by their warm, patient names. The walls of dust have been rising and falling across the great deserts long before any human history began, and they will continue long after. Tonight, somewhere across the warm Saharan world, a soft dust storm may be passing across an empty plain. The wind is moving fine grains of warm sand and silt. The sky is gently amber. A distant fennec fox is curled into its burrow, ears folded back. A camel is lying patiently in the warm shade. The wind walks. The desert waits. Slowly, the storm passes on. After the warm sun has set, the great desert reveals one of its quietest treasures. Far from any city, with no light pollution and very little water vapor in the air, the night sky over a desert is one of the clearest on Earth. The stars are uncountable. The Milky Way runs across the sky like a soft band of pale cosmic silk. The clarity of the desert sky is a gift of the dry air. Water vapor in the atmosphere scatters starlight and softens the contrast between bright stars and dark sky. In the desert, the air contains very little moisture. The stars stand out cleanly against the deep dark. Even faint stars become visible, and the patient pattern of the constellations becomes much easier to see. On a particularly dark night, far from any town, a careful observer can see between 2,000 and 3,000 individual stars with the unaided eye. From a city, the same observer would be lucky to see 100 or 200. The desert sky is not just dark, it is more than 10 times richer than the sky most people ever see in their daily lives. The Milky Way is the soft side-on view of our own galaxy from inside it. The pale band running across the desert sky is made of countless billions of distant stars, blended together by distance into a soft glow. Dark patches within the band are clouds of cosmic dust that block the light of the stars behind them. The patient, slow shape of the galaxy is gently visible to the unaided eye. In the southern Sahara, the constellations of the southern sky become visible. The Southern Cross can be glimpsed close to the southern horizon. Centaurus, with its bright nearby stars, sweeps across the lower sky. The northern constellations, Cassiopeia, the Big Dipper, the Pleiades, are still high overhead. The sky over the desert offers an unusually wide and gentle range. The Tuareg and the Bedouin have known the desert stars for many generations. Several of the brightest stars carry old desert names: Aldebaran, Algol, Vega, Betelgeuse, names that come from the slow, patient knowledge of Arabic-speaking astronomers more than 1,000 years ago. These soft, warm names still appear in modern sky maps, a quiet legacy of the desert. Our navigation is one of the oldest patient skills of the deep desert. By watching the rising and setting points of certain stars on the horizon, a desert traveler can determine direction even on a moonless night. The North Star, Polaris, sits almost exactly above the rotational axis of the Earth. Across the northern hemisphere, including the Sahara, it is the steady reference point of the night. Bedouin shepherds have long used the rising of certain stars to mark the changing of the seasons. The reappearance of the Pleiades in the dawn sky, after months of being hidden by the sun, signals the approach of summer. The high passing of Sirius, the brightest star in the night sky, marks the deepest warm part of the year. Each star carries its own quiet, patient calendar. In southern Egypt, near the modern city of Aswan, lies Nabta Playa, one of the oldest known stone observatories. 6,000 to 7,000 years ago, a small group of patient nomadic people raised tall stones in careful alignment with the rising sun on summer mornings. The site is now a quiet circle of warm-weathered stones in a flat, warm plain. In modern times, the deserts of the world have become the most important homes of professional astronomy. The dry air and clear sky provide ideal observing conditions. The largest telescopes on Earth are placed in warm, dry places. At the edge of the Atacama Desert in northern Chile, on the Hawaiian volcano of Mauna Kea, in the Roque de los Muchachos Observatory of the Canary Islands, and at the Paranal Observatory in Chile. The Atacama Large Millimeter Array, called ALMA, is one of the most patient instruments ever built. It consists of 66 radio telescopes spread across a high, warm plateau in the Atacama. By combining their signals, the array creates an effective telescope many kilometers wide. ALMA can detect the gentle radio glow of newly forming stars in distant cosmic regions. The Very Large Telescope, also located in northern Chile, consists of 4 8-meter optical telescopes that can be combined into a single virtual instrument. Its observations have helped astronomers measure the distance to faraway stars, study the atmospheres of exoplanets, and watch the gentle dance of stars near the supermassive black hole at the center of our galaxy. Many other observatories and astronomical sites lie scattered across the world's warm, dry regions. The Australian outback hosts radio telescopes in remote desert lands. The Karoo Desert in South Africa is the home of the Meerkat Array and is part of the Future Square Kilometre Array. Each of these patient instruments listens quietly to the gentle radio glow of the cosmos. Meteors are a particularly soft pleasure of the desert sky. On any clear night, a patient observer is likely to see several streaks of warm light passing across the dark. Each streak is a small fragment of cosmic debris burning up briefly in the upper atmosphere. During the major annual meteor showers, the rate can reach 1 or 2 per minute, gentle and quiet against the background of stars. Comets, when they appear, are particularly beautiful from the desert. The dry air allows the soft, fan-shaped tail of the comet to be seen clearly against the dark background. A slow, patient comet may be visible for weeks, gradually moving among the stars as the warm desert turns slowly beneath it. Each visible comet is a small, soft visitor from the outermost reaches of the solar system. The desert sky also offers gentle lessons in patience. The constellations rise and set on a precise schedule. The same stars return at the same hours, at the same times of year, century after century. Whatever else has happened on the surface of the warm earth, the patient, slow movement of the night sky has continued in the same gentle, patient way. Tonight, somewhere across the great deserts of the world, an astronomer is watching a distant, warm cosmic glow through a large, patient telescope. A Tuareg traveler is using the same stars to find his way home. A small Fennec fox is hunting under the gentle starlight. The sky overhead is quiet and patient, exactly as it has been for many billion patient years. From the warm sand seas of the Sahara, we now travel softly across the world to a different kind of desert. It lies along the western edge of South America in northern Chile. It is called the Atacama, and although it is much smaller than the Sahara, it holds a remarkable record. Some parts of the Atacama have not seen measurable rain for hundreds of years. The Atacama covers an area of roughly 105,000 square kilometers. It runs along the warm western coast of South America for nearly 1,000 kilometers between the cold Pacific Ocean to the west and the high Andes Mountains to the east. To its north lies the dry coastal Peru. To its south lies the gentle Mediterranean climate of central Chile. The Atacama is dry for several patient reasons. The high Andes to the east block almost all the moist, warm air rising from the Amazon basin. The cold Humboldt Current, flowing along the Pacific coast, cools the air along the shore and prevents most evaporation from the warm sea. The combination of mountain shadow and cool sea creates an extreme rain shadow over the desert. Average rainfall in the Atacama is only about 15 millimeters per year, and in some places it is far less. The town of Arica on the warm Atacama coast receives an average of less than 1 millimeter of rain in a typical year. In the deepest interior, near the patient Andes foothills, scientific weather stations have recorded long stretches of years with no measurable rain at all. Some weathered rocks in the Atacama have been exposed to the air for millions of years without the gentle washing of regular rain. They are slowly worn only by occasional fog drift and by the patient warm wind. The desert holds some of the oldest exposed land surfaces on Earth. gentle, warm, patient stones that have been quietly waiting for far longer than most other places. Despite its extreme dryness, the Atacama is not entirely lifeless. Along the warm Pacific coast, a thick, low fog called the Camanchaca rolls in regularly from the cold sea. The fog drifts inland during the night and condenses gently on plants and rocks. A few hardy plant species, small lichens, cushion plants, and a soft, pale cactus called the copao have learned to drink the fog directly. In some patient parts of the Atacama, the ground is white rather than red. Vast salt flats lie in the deep basins of the desert. The soft, warm remains of ancient lakes. The largest is the Salar de Atacama, which covers about 3,000 square kilometers. From above, the salt flat looks like a great pale mirror, gently broken by darker veins of sediment. Beneath the salt of the Salar de Atacama lies a particularly valuable patient deposit. The brines below the salt crust contain very high concentrations of lithium, the lightest of all the metallic elements. Modern lithium is essential for the rechargeable batteries that power phones, electric cars, and many other quiet machines. A large fraction of the world's lithium comes from this single warm Chilean salt pan. The Valle de la Luna, or Valley of the Moon, lies near the small Atacama town of San Pedro de Atacama. Its weathered formations of sandstone and salt look so unlike any other part of Earth that it has been used as a natural setting for science fiction films and Mars analog research. The patient warm rocks have been carved by countless dry years of wind and slow erosion. Higher up on the Andes Plateau above the desert lie geyser fields and volcanic peaks. The geyser field of El Tatio, at an altitude of more than 4,000 meters, contains more than 80 active geysers. They are most active in the cold mornings when soft white plumes of steam rise gently into the warm desert sunrise. The whole valley becomes briefly filled with quiet steam. Because the Atacama is so dry, so high, and so far from any major source of light pollution, it has become one of the most important places for astronomy on Earth. Many of the world's largest optical and radio telescopes are located on its high, warm peaks. The patient air of the Atacama is so steady and clear that fine cosmic detail can be seen with extraordinary precision. The dryness of the Atacama has preserved many ancient cultural treasures. The Chinchorro mummies found along the warm Atacama coast are the oldest deliberately preserved human remains in the world. Some of them are more than 7,000 years old, older than the Egyptian mummies. The patient, dry, warm air has kept their soft features quietly intact for many thousands of years. Indigenous Atacameño people have lived in the warm desert for many thousands of years. Their patient settlements, often built of adobe and warm stone, lie in gentle valleys and small green oases. They cultivate corn, quinoa, and small fruit trees in carefully terraced gardens. The town of San Pedro de Atacama is the modern center of their long, quiet culture. Although the Atacama is most often dry, very occasionally an unusual warm rain falls. Once every 5 to 10 years, the El Niño weather pattern brings a gentle wet season to part of the desert. Within a few weeks, dormant seeds that have been waiting for years begin to grow. The dry, warm sand is briefly covered by a soft carpet of small flowers, the famous flowering desert of the Atacama. Vicuñas, the smallest wild members of the camel family, live on the high Andean plateau above the Atacama. They have soft golden tan fur, slender legs, and gentle dark eyes. Their wool is among the finest in the world, pre-Columbian peoples wove vicuña wool into ceremonial cloaks for kings. Today, the vicuña is patiently protected, and its small herds are once again common across the high desert. Flamingos live on the salt lagoons of the high desert plateau. 3 species can be found in the Atacama: the Andean, the Chilean, and the rare James's flamingo. They feed on small algae and tiny crustaceans in the warm, shallow water. Their soft pink feathers come from the pigments in their food. They stand in patient, quiet groups, sometimes hundreds at a time, in the bright, warm sun. Tonight, somewhere on the warm, dry plain of the Atacama, a vicuña is grazing in the cool moonlight. A flamingo is sleeping with one leg tucked into its body at the edge of a salt lagoon. A telescope on a high ridge is taking a long exposure of a faint, distant galaxy. The patient, driest desert on Earth continues its long, calm life, exactly as it has for many slow ages. Far across the world from the Sahara and the Atacama lies another great patient desert. It is called the Gobi, and it stretches across southern Mongolia and northern China. The Gobi covers more than 1 million square kilometers, about the size of France and Spain together. But unlike the warm Sahara, the Gobi is a cold desert where winter snow is common. In Mongolian, Gobi simply means waterless place. The desert lies on a high plateau, mostly between 1,000 and 1,500 meters above sea level. Its climate is extreme. Summer temperatures can reach 40 degrees Celsius. Winter temperatures can fall to -40 degrees, with occasional fierce blizzards. The yearly range is one of the largest on Earth. The Gobi is not only sand. Indeed, only a small fraction of its surface is covered by classical sand dunes. Most of the Gobi is made of bare gravel plains, dry steppe grass, and rocky uplands. The famous Kongoran Els, the singing dunes of southern Mongolia, are a notable exception. They rise nearly 300 meters from the surrounding plain in a long, warm, patient ridge. The Gobi is divided into several patient regions, each with its own particular character. The eastern Gobi is gentler, with green steppe and slow-rolling hills. The Trans-Altai Gobi, between the Altai Mountains and the Tibetan Plateau, is more rocky and dry. The Yungar Basin in northwestern China is sandier. Each region has its own slow climate and its own quiet wildlife. The traditional inhabitants of the Gobi are Mongolian and Kazakh nomads. For many centuries, they have lived in patient round felt tents called jurs, known in Russian as yurts. The jur is held up by a wooden frame and covered with thick, warm felt made from the wool of sheep. It can be raised or taken down in just a few hours. It is one of the most remarkable mobile dwellings ever invented. Inside a traditional jur, the floor is laid with rugs. The walls are softened with hangings, and a small iron stove sits at the center. The smoke rises through a single round opening in the roof. The whole space is warm in winter and cool in summer. In a single soft round room, an entire family can sleep, cook, host guests, and pass the long, quiet, patient seasons. The Bactrian camel is the great patient companion of the Gobi. Unlike the dromedary of the Sahara, the Bactrian has 2 humps, and its coat grows thick and shaggy in winter for protection against the cold. A Bactrian camel can survive in temperatures from 40 degrees Celsius in summer to -40 in winter. Few other large mammals tolerate such an extreme range. Mongolian nomads of the Gobi traditionally herd 5 kinds of animals together: sheep, goats, camels, horses, and yaks. The combination is patient and well-suited to the harsh environment. Sheep and goats provide meat and wool. Camels provide transport and patient milk. Horses are used for riding and herding. Yaks, though more common in higher mountains, sometimes graze on the colder Gobi edges. The Bayanzog region of the Gobi is famous in paleontology. It is also called the Flaming Cliffs for the deep red and orange color of its sandstone. In the 1920s, the explorer Roy Chapman Andrews led an expedition that discovered the world's first known dinosaur eggs at this site. The cliffs continue to yield remarkable fossil finds to patient scientific work. Velociraptor, the small, fast predator made famous by modern films, was first described from Gobi fossils. Protoceratops, a small horned plant-eating dinosaur, was found in great numbers in the same region. One particularly remarkable patient fossil shows a velociraptor and a protoceratops locked in a long, quiet struggle, preserved together in a single piece of patient sandstone. The Gobi also holds the remains of many other ancient creatures. Mammals from the age after the dinosaurs have been found in great numbers, including very early relatives of the modern horses and rhinoceroses. Each fossil is a small, slow witness to the long, calm history of life on Earth, gently preserved by the warm, patient sand of the Asian desert. The Silk Road, the great patient trade route between Europe and East Asia, crossed the Gobi for many centuries. Caravans of Bactrian camels carried silk, spices, paper, and slow news through the warm, dry plain. Cities like Dunhuang on the southern edge of the Gobi became wealthy stops along the road. The Mogao Caves just outside Dunhuang hold thousands of patient Buddhist murals from this long, warm trading age. The snow leopard, one of the most beautiful and elusive of all the big cats, lives in the high mountains around the Gobi. Its soft, pale gray coat, speckled with darker rosettes, blends perfectly with the warm winter rocks. Snow leopards are very rare. A patient observer might watch the high cliffs for many days without seeing one. They walk alone and quietly in the cool, gentle light of the high mountains. Other Gobi mammals include the saiga antelope with its strange humped nose adapted to the dry, cold air, the Mongolian wild ass, the Pallas's cat with its thick, fluffy coat, and the Corsac fox, a small, soft, pale fox of the dry steppes. Each of them is patient, subtle, and adapted to the long, patient winter of the Asian desert. Mongolian Buddhism has long been practiced across the warm Gobi region. Small temple complexes, sometimes more than 1,000 years old, rest in quiet, patient corners of the desert. Their tall, warm prayer flags drift in the breeze. Their soft, yellow-roofed prayer halls are filled with the gentle smell of butter lamps. Many monasteries have been carefully restored after the changes of the 20th century. Genghis Khan, the great Mongolian ruler of the 13th century, was born somewhere in the wider Mongolian steppe. The Gobi was the patient, warm southern border of his empire. From its dry plains, his armies could move quickly in any direction. His patient, slow horses, accustomed to the harsh climate, were one of the great quiet keys to his historic success. Tonight, somewhere across the warm, cold, patient Gobi, a Mongolian family is resting inside a felt jur by a small iron stove. A Bactrian camel is sleeping nearby, its two humps soft against the cold ground. A snow leopard is moving quietly across a high ridge. The patient, long Asian desert continues its calm, slow life, exactly as it has for many quiet centuries. As we approach the end of tonight's quiet journey, we will visit one of the most remarkable patient stories in the history of our planet. The Sahara has not always been a desert. For long stretches of geological time, it has been green, covered in lakes, rivers, and grasslands, with herds of large animals grazing where the warm dunes now rest in soft silence. The most recent green Sahara lasted from about 11,000 years ago to about 5,000 years ago. Geologists call this period the African humid period, or sometimes the Holocene wet phase. During those slow, patient millennia, the climate of northern Africa was warm and moist. The summer monsoon rains, which today fall mostly south of the Sahel, reached far north into the warm interior of the modern desert. During the African humid period, much of the central Sahara was covered with shallow lakes. The largest of these, called Lake Megachad, covered an area larger than the modern Caspian Sea. Other large lakes filled the basins of what is now the Badile Depression in Chad and the Fasan Basin in Libya. From above, the green Sahara would have looked like a soft, warm patchwork of grass, woodland, and gently shining patient water. The lakes of the green Sahara were full of life. Fossil bones of crocodiles, hippopotamuses, and large fish have been found across the modern desert in places that are now thousands of kilometers from any open water. In the rocks of central Algeria, paleontologists have unearthed the bones of giant catfish, soft-shelled turtles, and even the remains of small early whales from much earlier, warmer, wet phases. On the soft grasslands around the green lakes, large mammals once grazed in patient, quiet herds. Bones of giraffes, elephants, water buffalo, and many species of antelope have been found in places that are now warm, dry sand. These animals roamed slowly through a Sahara that had more in common with the modern Serengeti than with the dry, warm world we see today. Humans also lived across the green Sahara. Small bands of patient hunter-gatherers and later small groups of pastoralists with cattle made their warm, slow lives in the open country. Their small settlements were located near the lakes and the shallow rivers. They left behind grinding stones for grain, small bone fishhooks, and many quiet pieces of warm pottery. The greatest patient record of green Sahara life is found in the rock paintings of the central Saharan plateaus, the Tassili Najer in Algeria, the Tadrart Akakus in Libya, the Endadi Plateau in Chad, and the Gilf Kebir in Egypt. All hold many thousands of warm paintings on their patient sandstone walls. The oldest of them are nearly 10,000 years old. The early paintings show large wild animals, giraffes, elephants, hippos, and herds of early cattle. The slightly later paintings show domesticated cattle, sheep, and goats, as well as small human figures dancing or tending herds. The latest paintings show camels, which only arrived in the Sahara when the desert had already become much drier. Each layer of paintings is a quiet record of a different climate. As the African humid period slowly ended, the soft monsoon rains gradually retreated southward. The lakes shrank. The grasslands faded. The animals migrated south or southeast. The warm, patient people followed, settling along the more reliable green corridors. Many of them moved to the warm floodplains of the Nile, the Niger, and the Senegal rivers. Many believe that the rise of ancient Egyptian civilization was tied to this slow, quiet exodus. The drying happened gradually. Modern climate models suggest that the Sahara dried out over a period of about 1,000 years, between roughly 6,000 and 5,000 years ago. The process was uneven. Some pockets of green remained for several thousand years longer than others. The Tassili Plateau still held small lakes when the Egyptian pyramids were being built far to the east. By about 5,000 years ago, most of the modern Sahara had become roughly as dry as it is today. The lakes that remained were smaller. The grasslands had become a desert. The patient memories of the green years lived on in the rock paintings and in the slow oral traditions of the peoples who had migrated south. The desert had taken its modern warm shape. The drying was driven by gentle, slow changes in the orbit of the Earth. The orientation of our planet's axis shifts patiently over a cycle of about 23,000 years. As the orientation changes, the strength of the summer monsoon over Africa shifts gradually. During the Green Sahara, the monsoon was at its strongest. As the orbit moved on, the monsoon weakened and the desert returned. The same patient orbital cycle continues today. According to climate models, the next Green Sahara is likely to begin about 10,000 years from now, when the orientation of the Earth's axis brings stronger summer monsoons back to North Africa. The slow alternation between green and dry has been continuing for many millions of years. The current dry phase is just one of many. The Bodele Depression in Chad, today one of the warmest and dustiest places on Earth, was once the deepest part of Lake Mega Chad. The very fine warm silt that the wind now lifts from its surface was originally laid down at the bottom of that ancient lake, made of countless tiny diatom shells. The Saharan dust that still patiently fertilizes the Amazon rainforest comes mainly from this single old lake bed. Some patient evidence of the Green Sahara can still be found in the modern desert. Wadis carved by ancient rivers run for hundreds of kilometers across what is now warm sand. Fossilized roots of long dead trees still rest in cliff walls. Small, isolated relict populations of fish and amphibians, somehow surviving in the deepest oases, are direct descendants of those that once filled the green Saharan lakes. The story of the Green Sahara is also a quiet lesson in patience. The same warm landscape we now see as endless dry sand will, in a much larger time span, return to grasslands and lakes. The same dunes will yield to soft pastures. The patient, slow rhythms of climate continue to shape the warm continent in ways that lie far beyond the brief span of human history. Tonight, in the warm sand of the modern Sahara, beneath the patient stars, the soft ancient rock paintings still rest on their warm walls. The fossilized whale skeletons still rest in their wadis. The dry lake beds still rest in their basins. Each one is a small, soft witness to the patient, long history of a continent that has been green and dry, dry and green many times before. Thank you for staying with us this long. If sleep is closer now than it was when we began, then this night did its work. Subscribing helps us return next week with another slow journey through the patient world of the great deserts of our planet, recorded with the same patient voice you have been listening to tonight. Sleep well and good night. The dunes are still slowly shifting tonight, the sand moving grain by grain across the long, flat plains. The oases are still drinking quietly from their hidden springs. The camels are still resting in the warm shadow of the date palms, exactly as they have for thousands of patient years. You do not need to remember anything from tonight. The story will be here again the next time you need it. Good night from the Circadian Institute. And with that, we bring tonight's quiet journey through the great deserts of our planet to a soft close. The dunes are still slowly shifting. The oases are still drinking from their hidden springs. The camels are still resting in the warm shade of the date palms. The wind is still walking patiently across the warm sand. They will all continue without us. Sleep softly tonight.